Okay, just a little recap or a piecewise functions and a couple of different things to look at in terms of piecewise functions. First thing we're going to do is we're going to match. And what I like to look at when we match, let's try to make this as easy as possible. I like to look at the boundaries. And I see that we have we have 1 as a boundary there. We have 1 as a boundary there. We have 1 as a boundary there. We have 0 and 0. And then the only one with -1 as a boundary is number 4 here. So let's go find which of these 6 graphs have, this has 1 as a boundary, 0 as a boundary. There it is. -1 is a boundary. Now let's examine that one. I'm going to erase those things because they're bothering me. But notice I've got the graph of, and I like to look for the horizontal, y equals -5. That's y equals -5. They're counting by 2's here. I've got an open circle right at -1 going to the left. And this is the graph of 3x minus 1, up 3, right 1. There's my y-intercept of 1. So number 4 is clearly C, and that one's done. Next, I saw 2 of them that had y equals 1. So let's go find the 2 of them, or excuse me, there was 3 of them. 2 of them had y equals 0. So here's one that has its boundary point at 0, and here's one that has its boundary point at 0. So let's see if we can figure out which of these is which. This one has a shared point, which means we're going to have a y-intercept of 4 and a y-intercept of 4. Well, look at here. Y-intercept of 4. Y-intercept of 4. This has got to be it. And then I have a slope of 2 going up to the right. It's steeper. I have a slope of 1 going down to the left. This one has to be B. That means that this one over here, again, I have a y-intercept of 3 and a y-intercept of 4. Y-intercept of 3 is a closed circle, and it has a slope of 2 going to the right. Y-intercept of 4 is an open circle, and it's got a slope of 1 going down to the left. This one has got to be F. All right, and then I've got my, these 3 are left, and they all have a 1 in them. I see this one has a horizontal at -5. So let's go find which of these has a horizontal at there it is, -5. -5 going to the right of 1 with an open circle. 6 has to be A. So I'm not like going through and doing these. I'm just using process of elimination to figure it out. And then let's see, what can I look at for these last 2? They're quite different. I've got a y-intercept of -4. That's probably important. This one would have not have a y. No, actually -2 and +2. Look at, if this kept going, it would cross at +2. This one's at -2. This has got to be D, and this one has to be, number 1 has to be E. How come? Because I've got a -4 for a y-intercept. Put in a boundary point, I get -3, 1, -3, closed, and then I'm going down to the left. All right, good stuff. Okay, evaluate each of these. Now you got to pick the right function. So like 1 through 4, you're using the F function. 5 through 8, you're using the G. 9 through 12, you're using the H. And you got to pick the right one. 2 is greater than 0, so my answer is 2. -4 is less than 0, so my answer is 3. 0 is equal to 0, so my answer is 3. 1/2 is greater than 0, so my answer is 2. So those ones were just horizontals, and you're picking the line. G of 7. 7 is greater than 3. I need to use the bottom one. 14 minus 1 is 13. G of 0. 0 is less than 3. I need to use the top one. 0 plus 5 is 5. -1 is less than 3, so -1 plus 5 is 4. G of 3. 3 is equal to 3, so I use the top one. 3 plus 5 is 8. Now I'm on to H of -4. -4 is less than -2. We use the top one. 1/2 times -4 is -2 minus 4 is -6. If you're not sure, hit pause, check your calculator. H of -2 is equal to -2, so I'm going to put it up top. Half of -2, -1 minus 4 is -5. H of -1, -1 is greater than -2. They're trying to goof you there. So I put a -1 in there. 3 minus -2. 3 plus 2, that's 5. I bet you that's the one that kids get the wrong the most. 6 is greater than -2, and I put a 6 in there. 3 minus 12 is -9. Check your work on those. Oh, we got a word problem. Words in math class. Whatever are we going to do? Children under 5 cost no money. That's going to be very, very important. Children between 5 and 12 cost $10. Children between 12 and 18 cost $25. And then adults are $35. Now, they use the word inclusive here. It should be like 5 and under, so we're going to go from 5 to 12, and we're going to include 12 on that, and then we're going to include 18 on that, and then we're going to go over 18. They would probably kind of, this is kind of broken down for elementary school students, middle school and high school students, and then adults. Write a piecewise function for cost. So we're going to do the cost. Whoa, what happened there? What the heck happened there? Oh my gosh. Oh my gosh. I got issues. And you're like, no kidding. Let's see if we can find where we were. Okay, we were right here. So I'm going to do the, where's my pen? No, I don't have a pen. Okay. The cost of age, I'm going to do X because I know everybody likes to use X. I could have used A. And I could say, we have $0. The cost is $0 if our age is 5 and under. So I'm going to go less than or equal to 5. But you can't be a negative age, so we should probably put greater than or equal to 0. I guess if you're born, I guess you could do greater than 0. I guess if you're on the first day you enter the world, you could go to an amusement park. Your parenting skills may be questioned, but whatever. And then I got $10, and I'm going from, that's going to be greater than 5, and I'm going to go less than or equal to 12. I'm going to include the 12. That's what inclusive means. And then I'm going to go $25, and I'm going to go from, I'm going to go less than, what are we going to do? We're going to do greater than 12 because we paid $10 over there. And now I'm going to go to 18, but I'm going to include the 18. And then I'm going to go $35, and that's a whole lot of money to watch your kids get on rides. That's going to be for, that's just greater than 18, because the 18-year-olds were covered there. So again, to be a function, we have everything covered, greater than or equal to 0 for age. And now I'm going to graph them, and I'm going to go $0. So this is my money, and this is my age. Okay, so from age 0, is that, did I do that right? Yeah, I did that right. The x's, no, yeah, the x's yeah, we're good. Okay, so I'm going to go from here to age 5, and it's going to be closed, and that's fine. And then I jump up to $10, and it's open at age 5 because you paid down there, and we go over to age 12, and we close it up. And then at age 12, I jump up to $25 once I turn 13. Ooh, I'm a teenager. Look at me now. Look at me now. Cost me more money. And I'm going to 18, which is here. I'm an adult. I can go to prison. And now I'm going to go up to 35. And they're going to say 18 is okay. And we're going to go like this. And is it going to infinity? No, but I suppose if you're 102 years old, you can still go to an amusement park, and it's probably going to cost you $35. In fact, this is probably a good time to say, you know, realistically, they might have a senior citizen discount too, like age 55 or age 60. They might cut that back down to $20. A lot of places do that. This is actually, this is a piecewise function, but this is called a step function. And you see a lot of step functions for pricing, especially like hourly parking and things like that, because look at, you just step up. They're like you can walk on them, and they're steps as you go. So keep that in mind if you ever asked a question on a standardized test about a step function. It's just like you're walking up a step. Okay, and then the last one here, let's take a look at how to graph this is kind of what I'm focused on, because we've got a squared in there and we haven't dealt with our chapter on quadratics yet. But it doesn't mean we can't graph it. We can get some points by plugging in some values, and we know that it's probably going to be U-shaped because we've been exposed to that in our life, so we're going to be okay. All right, so I'm going to start by plugging in -5 and getting a boundary point. -5, and then I get -20 plus 11. -20 plus 11 is -9. So I'm running from -5, -9, and I'm going to plug this one into, I'm just going to get my two endpoints. I think rather than messing with this slope of 4 and all of that, let's just get the two endpoints and connect the dots. We know it's linear. -2 would be 8 plus 11 is 3. So I'm going to go -5, -9, and then I'm going to -2, positive 3. And then let's check it out. Up 4, right 1. Up 4, right 1. Up 4, right 1. I hit it. Oh, I didn't check my open circles and closed circles. Son of a gun. We're having fun. But I've got an eraser, so I'm going to be okay. Ah! Let's try that again. Okay. Where were we? -2, 3. And now I'm going down here. Okay, and now when I do this one, I'm just going to I'm going to put them in there. -2 squared is 4, right? You got to watch that. 4 minus 3. So I'm going to kind of make an XY table. I know we said we're not going to do that. You could get it off your calculator too, but -2, -1, 0, 1, 2. It's just easier if we're not sure. -2 squared is 4 minus 1 is 3. -1 squared is 1 minus 1 is 0. 0 squared minus 1 is -1. 1 squared minus 1 is 0. 2 squared is 4 minus 1 is 3. And now I know I'm U-shaped, and I'm going to be filled in on each end. So I'm going to go to -2, 3. Oh, that gets filled in. I'm going to do a different color for effect, because I can. -2, 3, -1, 0. 0, -1, 1, 0, 2, 3. And if you remember anything about parabolas, we are U-shaped. And I was filled in on each end. Okay. And now the last one, I am going to pick. Let's do magenta. I'm making this video at home. Gracie will love magenta. My endpoints are 2 plus 1 is 3. So I'm going to do 2, 3. And I'm going to do 8 plus 1 is 9. And this one would have been easy to do. It's a slope of 1. 2, 3, open circle. But I'm putting an open circle on something that's already closed, so we don't care. And I'm going to 8, 9. I like when these graph paper is nice, and it's closed circle. And I connect the dots, and there I go. And if they did ask me for a domain, I'm going from -5 to 8. And all of my circles are filled in, so I'm good. And my range, I'm going from -9, and I'm going up, and a bunch of stuff is double covered, but I'm ending at 9. No problem. Fill these guys in. You can get them right off of you can get them off of here if you drew a good enough line, right? I'm not sure. Might need to put this in because I got some nasty ones there. So you might need a calculator. I don't know. -5. So I'm on this one. Oh, I got -5. It's -9. Idiot. Okay, and then -3, that's going to be in here. -3 is -1, it looks like. I can get it off the graph, or I can put it in there. -12 plus 11 is -1. And then -2, now I'm equal to it, so I'm in this one. -2 is 3. That was right here because I'm in the parabola. 0, I'm in the parabola, is -1. 2, I'm in the parabola, is 3. So I did all these points already. And then 4 is the only one that's in the in this bottom one. 4 plus 1 is 5. And there we go. We're good. Bunch more problems to do for piecewise. Hopefully we're getting a lot better at it. Go get them.